Hello all, this is Sriharsha from Broadcom. This presentation is about an OVS offload feature called dynamic rebalancing. Let's go to the first slide. In the following slides, we will go through the problem and solution at a high level. Then we will look at the design and implementation of dynamic rebalancing for OvS-TC based offload, that is in the kernel mode. We will then take a look at the gaps and challenges to support this feature with OvS-DPDK or user mode offload. So here's the problem description. Sometimes a NIC that is offloading flows could run out of hardware resources. This is because offloading involves several hardware tables and resources, and each NIC has its own offload capacity. When a NIC is in this out of resource or OOR condition, new offload requests may fail. At the same time, flows that are already offloaded stay offloaded until they are deleted by OVS. If there are higher priority flows or more useful flows that cannot be offloaded, then such flows end up running in OVS software data path. This leads to inefficient utilization of NIC hardware as well as host CPU resources. So the question is, can the flows be offloaded and managed more intelligently? The answer is dynamic rebalancing. So this feature is already implemented in OVS for TC offload. In this slide, let's see the highlights of this existing design. There are 4 high-level steps in rebalancing offloaded flows. The first step is reporting when a NIC has exhausted its hardware resources. This is indicated by the NIC driver by returning no space error when an offload request fails due to resource constraints. And this error is reported back to OVS. The second step is marking the specific netdev to be in OOR state in OVS, which initiates rebalancing for that netdev. The next step is to start the process of selecting flows for offloading. The current design uses packets per second or PPS rate of flows as the criteria. OVS computes the PPS rate of flows on that network device. The PPS values are persisted across rebalancing iterations. The last step is the actual process of rebalancing flows based on the PPS rate. For each device that's in the out of resource state, higher PPS flows in software replace lower PPS flows in hardware. There is also a configuration option called Offload Rebalance to enable or disable this feature. And in the diagram, we can also see the layers that are involved in this design. OR error reporting is done by the NIC driver. OR detection is done in the DPF provider in vSwitch in the context of handler threads. Offload selection is done in the OvProto DPF layer by the vValidator thread. And the rebalancing is also done in this layer by the vValidator thread. Let's go to the next. This is the last slide. So here we want to look at the gaps, challenges, and potential solution to implement this design for OvS-DPDK or RTE-based offload. We want to leverage the design from OvS-TC that already exists as much as possible. We have listed some of the gaps here. We need changes in the DPDK poll mode drivers to report space error when an RTE flow create request fails due to lack of hardware resources. And this should be handled by the offload thread in OvS-DPDK by marking the netdev to OR state. So error reporting and detection should be okay. Next is the flow selection logic in the revalidator should also be sort of reusable from the existing implementation. But during the process of rebalancing, some kind of synchronization might be needed between the revalidator thread and the offload layer in OvS-DPDK. This is because offload request is handled asynchronously by a separate offload thread in OvS-DPDK. So this is something we need to take a closer look at. Apart from this, there is another key difference between OvS-TC offload and DPDK offload. With TC offloads, the data path flow is maintained either in the hardware if it is successfully offloaded or in the kernel data path. But with OvS-DPDK, the flow is always added to the user mode data path, and in addition, it gets offloaded if the device supports it. So this means while rebalancing flows in OvS-DPDK, insertion or removal of flows should be done only in the NIC or hardware, and the user mode data path flows maintained by the PMD threads should not be updated. So yeah, these are some of the gaps and challenges, and also some proposal. This brings us to the end of this presentation. Thank you.
Let's thank Hemal and Sriharsha once more, and welcome Hemal back to our stage here. So I'm looking for questions about this talk, and so far I'm not seeing any. Hemal, let me once again give you the opportunity to add some additional comments that you might have based on watching the talk this time.
Okay, yeah, thanks, Ben. I also want to thank on behalf of Harsha. It's too late for him. He's based in India, so he couldn't join. One of the things we want to highlight here with the community, we worked on this, Ben, you and others, on the TC flower, gave us good feedback on dynamic rebalancing. We do think this kind of offload is missing right now in OvS-TC. And what we propose here is just the initial proposal, but there is room to further enhance it in terms of what is the selection criteria, how the whole rebalancing logic works. So I would like to get more community involvement on this, because I believe this is or to make offload successful, any device is going to have some capacity limit that is not going to be. So we need to handle this problem. And by having that logic in OvS-DPDK similar to OvS-TC flower, as well as enhance both, will make just in general OvS offload solution much better.
That's a well taken point. So you've had multiple talks at this OVSCon, and I think they're on a theme. Do you have any sort of overall thoughts about your work as a whole, or where the future of OVS should be going? That sort of include themes from multiple of these talks?
Yeah, I think I go back to 2 years ago, Ben, if you recall, we had a panel on offload. That time, I believe the offload versus where we were with OvS, there was a significant gap. We have come quite far in these 2 years. So offload being part of the integrated solution in 2.16 for VXLAN and CAP-DCAP was a good milestone for OVS in general. I'm very happy with that. Also, other thing is, want to see as more and more offload solutions get deployed with the OVS, and of course there are hardware supporting it. We'll learn from this, and then we want to continue to be tightly engaged with as more features. Today there was talk on some additional offload, like the policing we were talking about, or incorporating some chipset related offload. So overall, we need to continue to enhance the architecture so that it is base offload friendly. And at the same time, we always have this control plane or fallback path on software, so we don't sacrifice any feature set when we do the offload. That's the general theme, and we are doing good progress on that.
All right, I'm glad to hear that that you see that there's been progress and that we're going in the right direction. Oh, it looks like maybe we do have a question. Yes, Frode Nordahl asks, what's the main reason to pursue offload through DPDK versus the existing kernel TC flower interface? So what are your thoughts there?
So my thought is there are two different sets or types of deployment model or applications or OVS. There are appliance type of applications where they prefer OVS or DPDK. And for that, generally you see very high packet rate or throughput requirements where offload helps. The kernel TC flower, it has own deployment model where typically integrated hypervisor and the kernel data path is being used. There are also benefits to offload the kernel TC flower. So I don't view this as or they both have their own merits. That's why we are pursuing offload solution on both. And we do have well-defined APIs for kernel. We have TC flower, DPDK, we have RTE flow.
Thanks a lot for that perspective, and thanks again for your work and for your talk. It's now time